Good afternoon, everyone. Today I am going to report about the pressure measurement. The learning objectives. At the end of this report, students are able to define what is pressure measurement, know what is standard unit of pressure, see the unit conversion, know the pressure classifications, and identify the best in selecting instruments. A standard unit of pressure. So first, what is pressure? Pressure means force per unit area. So the pressure is a measure of the force exerted on an object per unit area. It describes how much force is being applied to a particular area. Imagine you have a balloon and you squeeze it with your hand. The force you apply to the balloon is distributed over the area of contact between your hand and the balloon's surface. So the pressure is the amount of force per unit of that contact area. So next is the Pascal. The Pascal is the standard unit of pressure used to measure the amount of force exerted per unit. So the Pascal is a unit of measurement that allows us to quantify and communicate pressure values in a standardized and meaningful way. So here is the formula. P is equals F over A, where P is force in Newton and A is area in meter. So here is another pressure units. Number 1 is Pascal, number 2 is bar, number 3 is pounds per square inch, number 4 is technical atmosphere, number 5 is standard atmosphere, and the last one is Torr. So now, I will show you how to convert pressure units. So now, let's move on to the pressure classifications. So we have absolute pressure. The next one is gauge pressure, the differential pressure, the sealed pressure, and the vacuum pressure. So absolute pressure. This classification refers to the measurement of pressure relative to a perfect vacuum. Absolute pressure sensors can measure pressures both above and below atmospheric pressure. So if we talk about absolute pressure, it is used in various applications such as in engineering, meteorology, and fluid dynamics to accurately measure and analyze the total pressure of a fluid or gas. It is considering both its internal pressure and the surrounding atmospheric pressure. So next is gauge pressure. It is the measurement of pressure relative to atmospheric pressure. Gauge pressure sensors typically provide readings in units such as PSI or pounds per square inch, bar or kilopascal or kPa. So the gauge pressure is often used in practical applications where the atmospheric pressure is considered as a reference point. So the gauge pressure is only considered the pressure above the atmospheric pressure. Next is differential pressure. It involves comparing the pressure between two different points or across a device or system. It provides information about the pressure difference rather than the absolute pressure at a single point. So, the use of differential pressure is to measure and monitor the difference in pressure between two points in a system or across a device. It is allowing for the detection of flow rates, filter clogging, and proper functioning of equipment such as pumps, valves, and filters. It is widely used in industries such as HVAC, process control, fluid dynamics, and medical applications. Next is sealed pressure. It refers to the measurement of pressure relative to a sealed or enclosed reference chamber. The reference chamber is typically sealed at a specific pressure, allowing for accurate measurement of the pressure difference between the process being measured and the reference pressure. So, sealed pressure is included in pressure classification because it represents a specific category of pressure conditions where a system or container is sealed to maintain a controlled environment and pressure level. It is distinct from other types of pressure classifications such as atmospheric pressure or differential pressure. Next is the vacuum pressure. It is used to measure pressures below atmospheric pressure. It is often expressed as negative values relative to atmospheric pressure. Vacuum pressures sensors are employed in applications such as vacuum systems, vacuum chambers, and certain industrial processes. So, the vacuum pressure is a lower pressure environment achieved by removing air or reducing gas density. It finds applications in packaging, distillation, cleaning, scientific research, and electronics. So now let's move on to selection of pressure measuring instruments. So first is pressure range. Determine the range of pressure you need to measure. Instruments are available for low pressure, medium pressure, and high pressure applications. Ensure that the selected instrument can measure within the desired range. So selecting the appropriate pressure range ensures accurate measurement and prevents damage to the instrument due to exceeding its operational limits. The second one is accuracy. It is considered the required accuracy of your measurements. Different instruments have varying levels of accuracy, and the appropriate instrument depends on the application's precision requirements. So, selecting the desired accuracy in pressure measuring instruments ensures that reliability and precision of the measured pressure values, which is crucial for accurate data analysis and decision making in various applications. So the third one is a type of pressure. Identify the type of pressure you need to measure. It could be gauge pressure relative to atmospheric pressure, absolute pressure relative to perfect vacuum, differential pressure, difference between two pressures, or vacuum pressure. Choose an instrument suitable for the specific pressure type. So, selecting the appropriate type of pressure like absolute, gauge, differential, and etc. in pressure measuring instruments is necessary to ensure compatibility with the specific pressure conditions being measured and to obtain accurate and meaningful readings based on the reference point and context of the measurement. The fourth one is environmental conditions. Evaluate the environmental conditions in which the instrument will operate. Factors like temperature, humidity, corrosive or hazardous substances, and vibration can affect instrument performance. Ensure the selected instrument can withstand these conditions. So, selecting the appropriate environmental conditions, temperature, humidity, corrosive substances, and etc. in pressure measuring instruments is crucial to ensure their proper functioning and longevity, as environmental factors can affect the accuracy, reliability, and durability of the instrument in different operating conditions. The fifth one is media compatibility. It is considered the compatibility of the instrument with the media whose pressure you are measuring. Some instruments may not be suitable for corrosive or reactive media, while others may be specifically designed for such applications. So, selecting media compatibility in pressure measuring instrument is important to ensure that the instrument's materials and construction are suitable for the specific characteristics of the media being measured, such as corrosiveness, viscosity, contamination, and etc. It also preventing damage or malfunctions and ensuring accurate and reliable pressure readings. The sixth one is response time. Determine the required response time for your measurements. Some applications demand fast response instruments, while others can tolerate slower response time. So, selecting the appropriate response time in pressure measuring instrument is essential to ensure timely and accurate measurements, particularly in dynamic or rapidly changing pressure conditions, enabling the instruments to capture and reflect pressure fluctuations with minimal delay and provide real-time data for analysis and control purposes. The seventh one is display and output. Consider whether you need a local display in the instrument itself or if remote monitoring and data logging capabilities are required. Additionally, decide if you need analog outputs or digital outputs for integration with control systems. So, selecting the appropriate display and output options in pressure measuring instruments allows for convenient and user-friendly monitoring of pressure readings, as well as seamless integration with data acquisition systems or control devices, enabling easy interpretation, recording, and utilization of the measured pressure data in various applications. And the last one is the cost. Assess your budgetary constraints while balancing the desired features and performance. Different types of pressure measuring instruments vary in cost. To ensure the selected instrument provide a reasonable cost to performance ratio. So considering the cost in selecting pressure measuring instruments allows for finding a balance between budget constraints and the desired level of accuracy and functionality. And that's all. And the continuation to this topic is assigned to Miss Jamaica Tukau. That's all. Thank you. Have a nice day.